Okay, welcome to lesson 7 of my refresher course. Today I'm going to be talking about inequalities and absolute value. Okay, so we're going to start by solving linear inequalities. We'll have a few methods to do that. Then we're going to think about graphing solutions on number lines or describing the solutions using intervals. And then we're going to also understand absolute value as a distance, and then solve some examples, some modulus equations or some equations using absolute value. Okay, so that's the plan for today. Now, before we get started, just a quick refresher. Sorry, I did this here on my computer, so let me just fix that. Okay, so we have what we have this symbol here, right? We're going to be using this for inequalities. It means less than. The next one is less than or equal to. So it's the same thing except with basically an equal sign sort of snuck into it, right? The next one, greater than or equal to. Right? And so, yeah, we're always going to just have to know what symbol we're talking about before you set about solving them. Okay? So let's consider some examples, right? So we've got some inequalities. And, what I'd like to do is just sort of take it directly across and just imagine for a second that this was an equation, right? So x plus 5 is equal to 12, right? If that was the case, then it would just be like bring the 5 over to the other side, and it's x is equal to 12, like minus 5, x is equal to 7, right? Now, if we were to go ahead and plot this number onto a number line, right? So we just draw a number line, and then we'd have like our 0, and then we'd have our 7, right? Don't know, you'd never do this, but you can just make a big dot there where 7 is to represent that, okay? Now let's consider how this would change if it was an inequality. And the answer is that you almost do everything exactly the same way. So this tells me that x is less than 12 minus 5. So this tells me, so we're doing everything the same, but the answer is in the end that we actually then, x is less than 7 is our answer, right? So it means that like it's not equal to 7. So we draw a hollow point there, and then we, then we have a line going backwards like this, okay? Now this one here, when we bring it across, x greater than or equal to 5. And so when we go and draw our number line, we get our 0 and we get our 5. And what we're going to do is highlight 5 like this. And let me use a different color. So we go ahead and we highlight 5 like this. And now from here, then we just go out like this. So that's the way. So we can either write x is greater than or equal to 5, or we can write this. So we can show the number as so the difference between inequalities is that an equation will end up just giving you, like, for example, in this case, a single number, or for quadratics, you'd get two numbers and stuff. But for an inequality, you're going to get a solution set, and you can represent that solution set either, with an inequality expression like this, or like with a picture of a number line like this. Okay, so now let's say we're going to make a graph of yeah, so that's what I was just doing just there. So here it's like, x is less than 5 plus 3. So x is less than 8. And then because it's less than 8, we're going to like go ahead and go, there's 0. Here is 8. And then we have an open circle here, and then we go like this. Okay, so that's just a way to represent that. Okay, so now we're going to have these inequalities this time that involve multiplication and division. And this is where we potentially enter into a slightly tricky territory. And the slightly tricky territory that we can enter into is just given by this thing here, okay? So if we multiply or divide by a negative, then we have to flip the inequality. So let's just solve these things first. So if this was an equation, I would just divide it across by 3. So I've got x is equal to 12 over, sorry, x is greater than 12 over 3. And that tells me that x is greater than 4. And, I could draw that on a number line by just then sort of doing the, there's like 0, there's like 4, and then here is like, something like this, right? So that would be the way that I would do that. Similarly here, this would be like x is, x over 4 is less than or equal to 2. So that means that I multiply across by the 4. So x is less than or equal to 8. And we're done. So now we draw a second number line. We have our 0. This time we have our 8 up here. It's pretty badly drawn. Our 8 is up here, less than or equal to. So now we're like drawing, it could be equal to 8, but then it's going to be like from there all the way back to minus infinity. So this is how we then draw it. Okay, so here we come to the special conditions, and this is the only way that practically, like, working on inequalities differs from working on equations, right? So what's this thing here? So let me show you with the following example. So let's say we had like minus x was less than 1. Well, if this was an equation that minus x is equal to 1, multiply both sides by minus 1, you've got if minus x was equal to 1, that would mean that x is equal to minus 1, right? But what about this one here? Well, we can multiply both sides by minus 1, but if we do that, we have to change the direction of the inequality. Why do we have to do that? Well, if we actually do this again, but this time get the sign change that we want, not from multiplying by minus 1, but by bringing stuff from one side to the other. So I bring across the 1 onto the left-hand side, it becomes minus 1. I bring across the x onto the other side, it becomes a plus x. So this is just adding and subtracting where this one was multiplying. So if I just add the x over and bring it over like that, then I end up with, you see, minus 1 is less than x. In other words, x is greater than minus 1. Okay. So you can see the effect is that we just change direction of the inequality. What I end up actually thinking is that the same thing here happens with my equal sign, that it flips around, but it ends up just sort of like looking exactly the same because it's not different if it was flipped around, if it was flipped around. Okay, so this is the one thing we have to remember, that if we multiply or divide by a minus sign, then we're going to have to flip the direction of the inequality. So if we were to take this in again, well, we can have x, and we can have 6, and we can have divided by minus 2. But now we're dividing by minus 2. This was greater than 6, so now it's going to be less than 6. So x is less than minus 3. So then we go ahead and draw the number line. Here's my 0, here's my minus 3, and then here is, it's not equal to minus 3, so then it's like this, okay? Okay, perfect. So we've done everything there. Okay, so now we've got, inequalities that just get a little bit more complicated. So this is a little bit like your, solving an equation business. So I'm going to get rid of the 3 first of all, and then I'm going to get rid of the 2, okay? So the first one then is 2x is 11 minus 3. So the 3 is added on the left-hand side, so it's subtracted on the right-hand side. So 2x is less than 8. And then I'm over here with 2x is less than 8. So then that means that x is less than 4. So now I go ahead and I draw the line. I have my 0. I have my 4. X is less than 4. So it's going to be like this here. So, you can always have an example of a maths problem which is written in words. And I think these problems are kind of important because essentially with maths, we are ultimately, it's not true for all people who do maths, I suppose, but ultimately we're trying to be useful in the real world, right? And it's not like, the real world isn't like a maths problem. But what we can do is we can kind of model a real world like situation as a maths problem. Well, here it's easy to do that. So what we want to do is basically take that sentence there and then be able to translate it and write it down as a maths problem. Okay, so someone's saying like, I have a number, and if I double it and add 5, then the result is less than 13. So what they're saying is we have a number, call it x, we'll double it, 2x, and then we'll add 5 plus 5, and then it's less than 13. So you have to be able to just sort of extract that, okay? And that's the same example. Well, almost the same example. Sorry, 2x is less than 13 minus 5, and then x is, that's less than, well, this will end up being 8, and then we'll divide across the 2, so x is less than 4. And then we can go ahead and we can draw the number line. So we have like a 0, we have a 4, and then we have, we're not equal to 4, right? So we have a hollow circle there. Okay, so we have another one. 3x minus 4 is greater than 5. So let's do that. So that's like 3x is greater than 5 plus 4, and then that means that 3x is greater than or equal to 9, and that means that x is greater than or equal to 3. And let's just change the color. So we have our number line, we have our 0, we have our 3, and then we are going to be great. We could be equal to it, but then we're going to be equal or greater than that. And it's a graph with a closed circle. Okay, so this time, if we wanted to write the answers using intervals, like you could write it as x greater than 4, but you could also write it as this interval with this infinity symbol. So let's just have a quick look at this. The way to understand this is to look at it, just a graph of a number line, right? So we have our number line, and we have, let's say we have our 0, and we have our 4, okay? And now we go over, and we're going to say, okay, it's greater than 4. So a hollow circle there, and it goes off, okay? Now, what we have then is this this notation here, right? We have an open bracket, and we have like an open bracket or a closed bracket, okay, when we talk about intervals. So what does the open bracket mean? Well, the open bracket means, the open bracket beginning with 4 means that we're starting at 4 with our interval, so the orange bit of the line, but we're not including 4. The open bracket means we're not including 4. And then we're going up to the end. Now, I've just written an arrow here, and you can just say x is greater than 4. So you're not saying like, you're not saying there's any point that it has to stop, right? So what does that mean? It just goes on forever. And what's another way of saying forever? It goes on to infinity. So that's why we have an arrow. But the way to also write it would be like an infinity symbol like this, and then have an open bracket. You can never have a closed bracket with the infinity, because infinity is it's not a number. It's just like a sort of an idea, like that it goes on forever. So the way to write it is like this. And then the second example is this time going in the other direction. So we have, this time is my 0, here's my 3 this time. And this time x is less than or equal to 3. So let's, so we have to include 3. And this time we're going to go back like this, okay? Now, we always have to write our intervals. We always have to go from like left to right with our intervals, okay? So we're going to start with the first number. Now, what is the first number? Well, if we went all the way back here, it would be like minus infinity. So we're going to start with minus infinity, and then we're going to go up to 3. So it's minus infinity to 3, but we have a closed bracket here and an open bracket here because we're including 3. Okay, so it's another way to write the intervals, like it's using interval notation, right? Not using the greater than symbols and stuff. So your answer can be written as, like, for example, x is greater than 4, or it could be written down as the open interval from 4 to plus infinity. Right. Okay, so advanced linear inequalities. Sometimes variables appear on both sides. So what we have to do is just go ahead and treat this example just as if it's a we're going to go ahead and just do this example just as if it was an equation. So less than x plus 3. Let's bring all the x's to one side and all the numbers to the other side. So that would be 2x minus x, which would be, so 2x minus x less than 5 plus 3. So that's x is less than 8. Okay, so you can use the same technique. So just remembering, do exactly what you do for regular equations, except if you're multiplying both sides by -1, then you change the direction of the inequality. Now, we have these examples that are a little bit weird with inequalities that we don't have with equations. Like, we can have something like, like with an inequality, we could have 1 is less than x is less than 2, right? What we're saying there is that we have our sort of line, right? And then we have our number 1 and we have our number 2. And what we're saying is that, like, we're saying that, like, well, that 1 is less than x. So x is above 1, right? But then x is less than 2. So we're in here, right? Now, what we can take from this then is two different expressions. We can take 1 is less than x, or we can take x is less than 2. So this is the way we can cram two of these statements together, because if we wanted to, basically in order to get one of these intervals, we need a left side and we need a right side, right? So we have this can be our left side and this can be our right side, right? Where if we have like x is equal to, we couldn't have like anything ever like this because this wouldn't make any sense, right? Like we could never have this triple thing with an equation, right? In the same way, right? Okay, so what that means when we do these examples is we're going to start off with like -2 less than 3x plus 1, and then less than or equal to 10. And we're just going to split it into two different examples. So we have like -2 less than 3x plus 1. And then we have like, 3x plus 1 less than or equal to 10. And we just have the previous examples that we were working with. So let me bring, let's bring all of the numbers to this side. So we have -3 less than 3x. And now I'll divide it across by the 3. -1 is less than x, and we're done. And this time I bring the numbers to the right-hand side. So 3x is less than or equal to 9. So that means that x is less than or equal to 3. And there we have it. We can combine them back again. -1 less than x less than or equal to 3. We can go ahead and draw a number line. And there's my -1. Here's my 0. Here's my 3. And if -1 is less than x, then we have this. If it's less than or equal to 3, we have this, and then we just fill in a solid line in between. So this is the set that represents x. X is all of these values in here. It's this cut off of the number line. Okay. So yeah, so when we're doing the graphs, we always have to have an open or closed circle. We look at the direction of the, so we will have to have an open or a closed circle. We're going to look at the arrow that we put on, right? And then does the number line match the solution? So we would always want to have to check, compare. So what we have is a way to write the stuff algebraically. And algebra is really nice because it's really exact and we can do these calculations and factorizations and different things with it. We can manipulate these expressions. But they can be meaningless, right? But a graph is like the opposite. It's completely the opposite, right? It can be very meaningful. We can see from a graph like what's happening, but we can't really do anything with it. Like we can't calculate it. We can kind of maybe get an idea with it, but we can't. We can only kind of guess with it. Okay, so now let's talk about the absolute value. Okay, and the main thing I want to say about absolute value is that, like, if you take the absolute value of like 5, you just get 5 again. If you take the absolute value of -5, you get 5. So what this is doing, the absolute value is sort of killing the sign and just giving you a plus sign, right? But let's say, for example, if you were saying the absolute value of x is equal to 4, right? What you're saying with that is if we drew a number line and this was 0 and this was x, then the absolute value of x was equal to 4 would mean that the distance from 4 to here, that's 4. But there's two directions that we could go to. So we could also have our x over here, and that's also going to have a distance of 4. It's just going to be in the other direction, okay? So what we're going to say is that the absolute value of x equal to 4 means two possibilities. Either x is equal to 4 or x is equal to -4. So basically, what number could we sub in here into the absolute value signs to get out a 4 or to get out a -4? And then when we have another one inside here like this, you see this x minus 3 is basically, we can think about this as being the distance from 3. So let me take a number line. Let me write the 0. Okay, so here's 3. And then this is, let's call that x. Now, what's that distance there? Well, that's x minus 3. But what if our x was on the other side? Then x minus 3 would be negative, is the point, right? We just want to talk about distance. Like if this is like, let's say this is where you live, and let's say this is the shop, and this is the school. Now the shop might be 1 kilometer away, and the school might also be 1 kilometer away. But you wouldn't say one is -1 and the other one's +1. Like you just think about how far you have to walk. Okay, so the absolute value just means, so the point is 1 kilometer away from your house could be either the school or the shop if you just had a straight line, right? If you said like one road or something.